Hello, everyone. You are welcome to Global Entertainment Educational Segment. My name is Abimbola Temitope, and I'm very excited to begin this educational adventure with you all. So today, we are working on a vital and one of the basic mathematics concepts, and the topic is called indices. Indices is one of the fundamental topics in mathematics. Indices even from primary school. Indices, the definition, is a plural form of the word index. Indices is a plural form of the word index. And when we're talking about index, another name for the word index is called exponent. If you are given something like this, yx is called power or index in mathematics. So the primary basic terms, when we have something like this, 2 raised to power 3, it means we have 2 in 3 terms. That means 2 times 2 times 2. And getting to know this one, in the primary basic level, we were taught something like this. But in this one now is another level entirely. How can we solve this in a normal way? This is 2 raised to power 3, which means 2 times 2 times 2. And this one will give us 8. So the 2 here is called basic number, while 3 is called power or index. In some form or in some textbook, you are going to see exponential. Okay, but when we are talking about indices and index, there are some rules or there are some laws that govern this particular topic. What are these laws? Now let's venture into that. Number 1, we call it the multiplication law. Multiplication law. When we talk about multiplication law says that the base, if we have a tantamount base or a commensurate base, I mean the same base, then definitely we're going to pick one base and the power we sum it up. For example, if we have a raised to power m times a raised to power n. With this now, because the base are equal, are the same thing. So what we are going to do is that we are going to pick one base, which is a. And then, because it's multiplication law, the power or the index, we sum it together, which is m plus n. For example, if I have 3 raised to power 2 times 3 raised to power 2. In this case, the primary level, you do like this. You say 3 times 3. Then we have another times here, times 3 times 3, which is going to give us 3 times 3, 27. 27, then times 3. This one is going to give us 81. Then 81 times 3, this is going to give us 243. That is primary level. But with this one now, we don't do like that. What we are going to do is that we notice that the bases are the same. So we just pick one base, which is 3. And then the power, we add it together, which is going to be 2 plus 2. 2 plus 2 will give us 3 raised to power 4, which is going to give us 243. So you can see it's the same thing. You can see we derive the same thing. But instead of widening your solution like this one, you can just solve it basically. Now, we call this multiplication law. Now, the second law, which is going to be number 2, we call it division law. We call it division law. And when we talk about the division law, it's almost commensurate with this multiplication law. But the only difference between them is that this one has times and this one a raised to power m divided by a raised to power n. You can see the only difference between them. I have a division sign, then I have a multiplication sign here. So the same thing is going to be applicable to this particular thing. So what we're going to do is that we're going to pick one base, which is a, then I have m, but the only thing different is that the power will change. The sign between the two power will change. What we have here is plus. So what we are going to have here is minus, which is m minus n. Let me give you an example. We have 3 raised to power 4 divided by 3 raised to power 2. With this, because the bases are the same, so I pick one base, 3, then I have 4, because the sign for the power is going to be minus. So I have 4 minus 2. And with this one, I have 3 whole number, which is 3 base, then raised to power 2. And this one is going to give me 9. It's going to give me 9. And that is the second law. We call it division law. We call it division law. And then number 3. Number 3, which is the third law under indices and index. We call it power law. Power law. When we're talking about power law, it means, let me give you an instance. We have a raised to power m, all brackets, n times of this. We call it power law. And when we talk about power law, it means when you look at this vividly, you are going to see that we have two index here. One is inside the bracket, while the second one is outside the bracket. So the power law is a little bit different from multiplication law. What we are just going to do here is that we're going to say a raised to power m, then you multiply both the index, which is going to be m times n. And this will give us a raised to power m n. Let me give you an instance. We have 3 raised to power 2 or raised to power 3. With this one now, what we're going to do here is that we're going to say 3 all raised to power 2, then times we have 3, which is the external index. And with this one now, we have 3 raised to power 6, then giving us 3 raised to power 6, which is going to give us another variables, which is, you can leave your answer like this if you like. You can leave it like this. You will get the same. Since we are talking about indices, it's all about the index. Remember, it's all about the index. Now, that is that one. Do you know this power law is somehow tantamount to this multiplication law? Because what I have here is that I have 3 raised to power 2, how many times? 3 times. In which I can also do it in a primary level like this. I can say 3 raised to power 2, 3 times is going to be times 3 raised to power 2 times 3 raised to power 2. And with this one now, what am I going to get? I pick one base, which is one variable, which is going to be 3 all raised to power. If you could remember, you remember that when we are talking about multiplication law, the power or the index will add up everything, which is 2 plus 2 plus 2, then giving me 3 all raised to power 6. You can see we derive the same answer. Now, that is all about power law. Number 4. Number 4, we have what we call zero law. Number 4, zero law. when we talk about zero law in mathematics, even this is a common law that everybody knows. Now, in mathematics, when we say zero law, it means any variables raised to power 0, it will give us 1. Any base raised to power 0, integer raised to power 0, it will give us 1. For example, this is the law. A raised to power 0 will give me 1. A raised to power 0 will give me 1. And I want you to note something, that A is not equal to 0. Remember, my base is not equal to 0. But because my base is raised to power 0, definitely is going to give me 1. Another one, if you have something like this, 8 raised to power 0, it give me 1. 1000 raised to power 0, it give me 1. Now, but I want you to note something, please. There's difference between these. Note, please, between minus 3 raised to power 0 and minus 3, all bracket close, minus 3 raised to power 0 without bracket. Please take note of this. This is very important. When you have minus 3 raised to power 0, it means that this 3 owns this minus because we have bracket here. And the answer here is going to give me 1, which is going to be positive 1. Now, likewise, when we have minus 3 raised to power 0 without the bracket, what we are going to do is that we are looking at this without the bracket, is that there is minus 1 at the front of these 3, which is minus 1 times 3 raised to power 0. Minus 1 times 3 raised to power 0. And if you look at this very well, you are going to see that the 3 raised to power 0 will give me what? 1, which is going to be minus 1 times 1. And my answer is what? Minus 1. So there's difference between minus 3 raised to power 0 or bracket and minus 3 raised to power 0 without the bracket. Let me give you another example. We have minus 5. This one is different from 0 principles or 0 law. Just want to give you this so that you will know the difference between these. Minus 5 raised to power 2 and minus 5 raised to power 2. Look at the 2. This one is enclosed. This one is without bracket. Now, when looking at this, you see this, what they are saying in short is that minus 5 twice, which is going to be minus 5 times minus 5. And minus times minus, we cancel. Then we have 5 times 5 will give me positive 25. And if you look at the second one, like I've said earlier on, I said without the bracket, once you see minus, it means there is 1 in front of it according to the principle, which means that we have minus 1 times 5 is how many times, which is 5 raised to power 2, minus 1 times 5 times 5. Then 5 times 5 is going to give me 25. Minus 1 times 25 will give me minus 25. Can you see the difference between the minus 25 and 25? I believe you understand. Okay, now that is the zero law, which is the first law of indices. Number 5 law, we have what we call negative index law. Number 5, negative index law. And what we're talking about negative index law, this says that if I have a base raised to a negative index or a negative power, it will be equal to the reciprocal or the inverse of that base raised to the positive integer. Now, this is what I'm saying. A raised to power minus n. If you look at the index here, the index, there is minus in front of the index. So what we are saying in a nutshell is that whenever you see minus in front of the index, a whole number index, it means that what we are saying is that there is an inverse here. And what is the meaning of inverse? It means 1 all over the minus is the 1 all over, which is the inverse. That is what the law says. 1 all over. So what is left is what? A raised to power n. Because the minus has been converted to the inverse. Now, for example, if I have something like this, 2 raised to power minus 3, 2 raised to power minus 3, it means that when you look at the minus, that is the inverse there. It means minus, 1 all over. So we've turned the minus, the negative form, to 1 all over. So what is left now is 2 raised to power what? 3. And this one will now give me 1 all over 2 times 2 times 2. Then that is 1 all over 8. That is 1 all over 8. Now, another one, let me give you more examples on this inverse. Let me give you another example on this inverse. And do you know that when we are talking about this, okay, let me rephrase this very well so that you will understand better. Now, this particular a raised to power minus n, how do they derive this? It means a raised to power 0 all over a raised to power n. And if you look at this, if you could remember very well, our zero law says that anything, any variables or terms raised to power 0 is equal to 1. Then all over a raised to power n. You can see, we still get this. So it's the same thing. I believe you understand. Okay, then number 6 law. Number 6 law. Number 6 law. Number 6 law is what we call fractional index law. Fractional index law. Fractional index law. For raised to power m over n. If you look at this one, you are going to see that it's a little bit different. We don't have any fraction from the inception. We don't have any fraction. So what we have here is a raised to power m all over n. And if you could remember, this m all over n, this one is called numerator. Why this one is called denominator? Numerator, denominator. So what this is telling us, what we're talking about the fractional index law, is that n roots of a, the all bracket m. N root of a, you will use the denominator to root your what? Your base number. And you will what? You will power it or you will index it. So this is what I'm saying. It means that n root of what? What is the base? A. Then all bracket, what is the numerator? All bracket m. All bracket m. It means that whatever we have at the denominator level, we root your base number, and after that, then you will what? You will power it by the numerator. For example, if you have something like this, 9 raised to power 3 over 2. With this now, what do we have here? What is my numerator? My numerator is 3, while my denominator is what? Is 2. So what we are going to do here is that we are going to take these 2 to root my what? My base number. I believe you understand. Like this, we have the what? The square root. We have the square root or the second root. If I put 2 here, it's going to be the second root of what? Of 9. all raised to power what? All raised to power 3. It's the same thing as the square root of 9, all raised to power what? All raised to power 3. Now, this and this is the same thing. I mean, the second root of 9, all raised to power 3, and the square root of 9 raised to power 3. Now, let's find this. Let's complete this. With this now, the square root of 9 means that what number, what times? We're going to times 2 times. What times? We're going to multiply twice. That is going to give us 9. What times are we going to multiply 2 times that will give us these variables? What is the number? Okay, somebody said 3. Okay, that means we have 3 is here. And you know, if you say 3 times 3, it's going to give me 9. So this is 9. And the variables of this second term, second root of 9, is going to be what? 3. Just pick only one. So 3. Then remember that we have an index outside here. So all raised to power what? 3. Which means all raised to power 3 means 3 times 3 times 3. And 3 times 3, 9. 9 times 3 is 27. Is 27. Okay? Let me give you another example regarding this. Another example. Now, if we have 8 raised to power 2 all over 3. Look at this. You see this? The numerator is 2, while the denominator is 3. What we are going to do with this is that we will use the denominator to root our base number. So what we are now going to do is that if you look at it, this is third root. The third root of what? Of 8 is the cube root of what? Of 8, or the third root of 8. Then remember that we have numerator. So we have all raised to power 2. With this now, what number? We are going to multiply 3 times the same number that we multiply 3 times and will give us 8. Okay, 2, yes. So 2, we have 2 times 2, 3 times 2. 2 times 2 is 4. 4 times 2 is 8. So getting 8. So that means our number is what? Is 2. The cube root or the third root of 8 is what? Is 2. And remember, the 2 has what? It has power. And what is the power? 2. And with this one now, it means 2 times 2, which will give me what? 4. Which will give me 4. Now, in another form, I want you to remember, please, remember, note, I want you to note that 3 roots 8 is different from third root of 8. Take note of this, please. 3 root 8 is different from third root of 8. This one is sword, is under sword. That means that what they mean here is that 3 times root of 8, which give me 3 root 8. You can see the 3 is not enclosed here. But when you look at this second one, it means cube root of what? Of 8. You can see the 3, where the 3 stands. And the 3 here is outside. So please take note of that. Take note of that. Okay. That is rule number 6. Then we move to rule number 7. Rule number 7, which is going to be my second to the last rule. Rule number 7. Rule number 7. The rule number 7, we call it product power rule. We call it the product power rule. The product power rule. And when we talk about the product power rule, is different from power rule. This one is the product power rule or power law. Okay? Product power law. And when we talk about the product power law, that means the base is not one. If you could remember when we are talking about the power law, I said a raised to power m or power n. That means we multiply the two power together. But when looking at this, it's going to be a product inside the what? The bracket. For instance, if we have AB or raised to power m, AB or raised to power m. This AB or raised to power m, there is a product. There is product between this A and B. And what is the meaning of product? It means times. Multiplication sign. It means I have A times B here. So A times B will surely give me what? AB. So all raised to power what? All raised to power m. And if we look at this, it's just like we are talking about twins. And a gift is given to twins. Definitely, that's a gift, not two, is given to twins. Definitely, and two of them are to share the gift. So what they are going to do is that what? They will share it equally. So now, what we have here is that we have A raised to power m, because the m is not meant for only A and it's not meant for only B. It's meant for the what? For the two variables. That means that we have A raised to power m times B raised to power m. A raised to power m times what? B raised to power m. Now, that is the multiplication aspect of it. What about if you have the division aspect of it, or we have A over B all raised to power m? It's the same thing, the same procedure. So the m is going to be shared between the A and the B. Like this. We have A raised to power m all over what? B raised to power m. I believe you understand. Now, for instance, let me give you example. Let me give you example under this. Let me give you example. Let me give you example. If we have 2A all raised to power 3, evaluate 2A bracket close all raised to power 3. It means that the 2 is not the only owner of this 3. The 3 belongs to the 2 and the A. So what we're going to do is that we're going to say 2 raised to power 3 according to the law, and what? And A times A raised to power 3. And if you look at this very well, 2 raised to power 3 means 2 times 2 times 2. Then times what? A raised to power 3. Now 2 times 2 times 2 times 2 is going to give me 8 times A raised to power 3. And my final answer is 8A raised to power 3. That is that. And I want you to note something, please. This particular law does not function with the addition and the subtraction rules. Please take note of that. For example, now I have something like this. People make mistake with that. For example, now you have A plus B all raised to power 2. This one cannot work. A plus B all raised to power what? All raised to power 2. So it's not the same. It's not the same as A raised to power 2 plus B raised to power 2. This is wrong. This is wrong. Please take note of that. And if you have something like this also, A minus B all raised to power 2 is not the same as A raised to power 2 minus B raised to power 2. So it doesn't work with the what? The addition and the what? And the subtraction rule. It only works with what? The multiplication rule. That is why we call it what? The product power law. Product means what? Times. The product power law. The product power law. And the what? The power will also be what? Equal. Once equal base, the power will also be what? Will also be equal. That means what we have here is that M will also be equal to what? N. Because the bases are the same. So the power will also be the same, no matter what we have here. So far the bases are the same, the power will also be the same. So we call it equal what? We solve one, that will give you one to, to practice while at home. Now, let's look at this question. The question says, this is Y question. The question says, we have simplify. We have simplify 9 raised to write your question in your solution. Then you're not going to say what? What is this? We call it second root. Second root of what? Of 9. 9 second root. So if you look at this, what is the second root of 9? We have 3. Yes, correct. Then times, what is the quadral root of 81? It means the same set of number. The same number I will multiply 4 times and it's going to give me 81. What is that number? Somebody said 3. Yes, that is 3 times 3 times 3 times 3. 4 times 3 times 3, 9. 9 times 3, that is 27. 27 times 3, 81. So my quadral root of 81 is 3. You know that this one is raised to power what? 1, nothing. And 3 raised to power 1 and 3 is the same thing. That is, if you look at this, 3 raised to power 3 or raised to power, what is this? Evaluate 6 raised to power 2 over 3, 2 over 3 times 8 raised to power 1 all over 3, then all over 12 raised to power 2 all over 3. Evaluate this. Evaluate this. That is all about indices 1. Though by next time that we'll be meeting, we're going to move to indices 2. And in that place, we'll be talking about the what? The equation form. Something like